In this video, I will explain how to solve capacity planning problems using Microsoft Excel. I'll be solving a few problems. So here is a first problem in the assignment. It says, determine the utilization and the efficiency for each of these situations. And the first one is a loan processing operation that processes an average of 7 loans per day. Okay, now the first step over here is that we need to identify what is this 7. It says a loan processing operation that processes an average of 7 loans per day. So which means this 7 is output. So please note this one. We can write here that this output, that 7 is output. So you enter data here, and then it says the operation has a design capacity of 10 loans per day. Well, this is straightforward. Over here, it's explicitly mentioned that 10 loans per day is design capacity. So we'll add here design capacity as 10. You can write here design capacity, or sometime you can also write in abbreviation, you can write DC. That's also perfectly fine. And then the next part is the operation has and an effective capacity of 8 loans per day. So again, this is very straightforward because it's mentioned that this is effective capacity. So I will write here effective capacity is 8. And then there are different parts, but we will be solving only one part. Other parts will follow the same process. So what we have to find, we have to find utilization and efficiency, because this is something that's mentioned here. Determine the utilization and efficiency for each of these situations. Okay, so we have to calculate utilization and efficiency. So this is the first part, that's about data. And it's mandatory that all this data is written here. And then we have next part that's called as utilization. That's calculating utilization. And for utilization, we have this formula. Now, as you can see here that in this case, I'm writing here utilization is equal to, I did not put is equal to sign here, because if I put is equal to sign here, it will convert this one into a formula, and it will give me an error. I will have to put some values. But over here, I do not want to uh, enter any values. I just want to show the formula. So therefore, whenever you want to show your formula, make sure that this equal sign here, that's after utilization, it is here and not here. Now, for example, I will show you, if I enter this equal sign here, then what would happen? So if I write here equal sign, then you see it gives me an error because it's expecting me that I should enter values. But that's not my objective. My objective here is only to show the formula. So therefore, I enter this equal sign after utilization. And the next thing is showing the process. And for that process, I will just write here output. We know this is output is 7 divided by design capacity is 10. So 7 over 10. And because this utilization, we always mention it in percentage. So I will multiply by 100. And again, I'm not expecting here an answer because I didn't put here an equal sign. I just want to show the process. Now, in the last step, we are going to do actual calculation. And for actual calculation, we know I will have to start it with an equal sign, and it is output divided by design capacity. So this is output 7 and divided by design capacity. And you can add here multiplied by 100, or there is another way. So if I hit enter, that gives me this 70%. Now, there is a possibility that in some cases you may not get this 70%, but you may get something different. But don't worry, just click here on this percentage and it will give you this percentage. Sometime it might just appear as a number, it might appear as 0.7 or something. But if you want to convert it into percentage, you just click here on the percentage and it will be converted. It will give us utilization, percentage utilization. And then another requirement is that uh, you show this answer to two decimal places. So for example, then I will click on this one. And if I click on this one, it's showing me two decimal places. So that is 70%. That's the answer we need. Now, as you can see here, in this solution, we have three parts. One thing is formula, and that's clearly shown here. Second thing is process, that's here. And the last one is actual answer. So these are the three parts that are required in your solution. And as I mentioned here, that this one, you don't have to mention here multiplied by 100, although you can also do that. But because we already have this option here in the ribbon, so if you click on this percentage, it will automatically be converted into percentage. So we don't need to multiply by 100 here. Okay, now let's go to the next part, and the next part is calculating efficiency. And you know, the formula for efficiency is equal to output over effective capacity. And as you can see here, again, I did not put an equal sign here, because if I put an equal sign here, then it will convert it into, it will be expecting that I need to enter some values. But my objective is not to enter here some values. I just want to show the formula. So therefore, make sure that this equal sign appears here. And with this approach, you will be able to show the process, the formula. In the next step, showing the process, or in other words, substituting the value. And again, over here, I'm not entering any equal sign. And output, what's our output? Output, we know this is 7. And what's effective capacity? Effective capacity is 8. So which means that my process here will become 7 over 8 multiplied by 100. Okay, now let's calculate it. And for that purpose is equal to output. This is output, and I will click on this one and divide it by effective capacity. And if I hit enter, it gives me 87.5. Now, again, there is a possibility when you will be doing it, maybe you may not get this answer 0.87, maybe you may be getting something different. But again, just click on this percentage sign and that will be converted into percentage. Or another way is that, for example, we say is equal to 7 divided by 8 multiplied by 100. So as you can see here, now this is erroneous. And the erroneous is that because I multiplied by 100, and also I also clicked on this one. So it means that we don't need to do enter this 100. We will just go 7 divided by effective capacity, and that's it. So if you manually add multiply by 100 and then click on this one, so that will be a duplication, and that will give you an erroneous result. So again, therefore, please make sure that when you are calculating efficiency, you are just dividing these numbers, output divided by design capacity or effective capacity, and then click on this one, and that's okay. And again, as you can see that for this part, there are three elements. One thing is process, and as the formula, you can see here that this is the formula clearly shown. And the second part is process, which is showing that we divided 7 by 8 and then multiplied by 100. And the last thing is your answer. And again, your answer, you can highlight it in any color you want, and please expand it to two decimal places. So for example, if this is just 87, I mean, if I reduce this decimal places, I mean, if I click on this one, so you see that's showing 88%, which is okay. But when we have this facility, so let's go ahead and expand it to two decimal places. So this is how we will be doing capacity related problems. And you will be following the same process for the next one. The next one is that a furnace repair team that services and averages of 4 furnaces a day. And if the design capacity is 6 furnaces a day and effective capacity is 5 furnaces a day, then what would be utilization and efficiency? You will be following exactly the same approach here. Now let's move to the next question. And the next question is calculating break-even point. And again, uh, so this is the question from the assignment. It says, a producer of felt tip pens has received a forecast demand of 30,000 pens for the coming month from its marketing department. Fixed cost is 25,000 per month. So what's a fixed cost? Fixed cost is the cost that does not change. It's fixed. It remains fixed. So for example, this company that are making some pens, they have invested in fixed costs. They have machines and uh, other type of expenses. That's called fixed cost. And we call them fixed costs because they don't change. And the next thing is variable cost of 37 cents per pen. So this is variable cost, which means this is the cost of making each pen. So every time they make a pen, the cost they incur on each pen is 37 cents. And we have to find the break even quantity if pens sell for $1 each. So that's another element, that's $1, that's a price. And we have to calculate break even point. And as you know, break even point is the point at which your revenues and your cost, they are equal. So break even, which means the quantity, and a break even is not the dollar amount, it's the unit amount. So for example, the number of pens. So break-even point is the point at which your revenues that are coming into your pocket and your expenses that are going out of your pocket, they become equal. And because your revenues and profits, they are equal, so your profit is zero. Because when you subtract cost from revenue, that gives you profit. And because they are equal, so revenues minus total cost is equal to zero. So break even quantity is the point at which our profit is zero, or in other words, revenues and total cost, they are equal. And again, we will start with the same approach. First, write here data, and the data is demand is equal to 30,000, and that's mentioned here, 30,000. And then it says fixed cost is 25,000, and then variable cost is 0.37. Now, this is an important point that needs critical observation. Uh, it says 37 cents. I cannot write here 37 cents because the thing is that other uh, quantities fixed cost is in dollar amount. So I cannot write here in one thing in dollar and other thing in cents. So that also need to be converted into dollar. And 37 cents, when you convert it into dollars, that would become 0.37. So by doing this, we make sure that all these units are consistent. Fixed cost is in dollars and variable cost is also in dollars, not cents. And then price is $1. And then we have to calculate break even. So that's the first step whereby you have to enter all data. And then we know the next step is showing formula. And again, you can see here for formula, I write here break even and then equal sign. And again, as I mentioned earlier, this equal sign is here, not here. If I write equal sign here, for example, I will show you here. If I write here equal sign here, it will give me an error because it will be expecting that I should enter those quantitative numbers. But that's not my objective. I only want to show the formula. So therefore, make sure you are doing this. And the next thing is showing the process. Again, over here, I'm not entering equal sign because equal sign would mean that I'm going to solve it, but I do not want to provide a solution here. I just want to show the process. So fixed cost, that's 25,000 divided by price is $1 minus variable cost is 0.37. So this is the process that's mandatory to show. And now we move to the last step, and the last step is whereby we'll be actually solving this problem. And that would be, as you can see here, the formula is fixed cost. So fixed cost is 25,000 and divided by. Now, you see here in the denominator, we have two things, price and variable cost. So I want to put them in parentheses. And price is 1 minus variable cost is 0.37, and I will close the parentheses, and if I hit enter, it will give me break even point. So once I hit it, it gives me this answer that's 39,682.54. Break even is about number of units, so which mean it literally means that it's actually 39,683. But we can it's always a good practice to expand them to two decimal places. So your answer should be this one, 39,682.54. And again, for break even, because break even is the number, it's a quantity of pen, it's not something dollar or not something percentage. So don't make this mistake of clicking on percentage here, because we are not talking about here percentage, that's a quantity. So this is how we calculate break even points.